Okay, alright, this is going to be our Lab 4 tutorial walkthrough. So any of you that are still having issues working with it, you will be able to see how to kind of get the guts, the base part of this done before you go through to start creating your cartographic decisions, your cartographic products. Alright, so I've already connected to my data. The first thing we need to do is to, well, first create a map. So let's insert new map. Alright, then let's add our data into our map. Now, we know it's supposed to be Wisconsin, but we didn't see anything pop up here. Let's go ahead and zoom to our layer. Alright, there's our pancake, Wisconsin. What's up with that? Why is it blue everywhere? Well, if we zoom out, we realize it's this microscopic guy down here off the coast of Africa. Oh, that's probably because this particular location is about 0, 0, so it's at the origin. So we know immediately something's going to be wrong with our projection. If we go into our properties, um, take a look at the metadata, we see there's nothing in here. If we take a look at our source, try to look at our spatial reference, we see there's nothing there. Well, step 2 of our lab asks us to take a look at our metadata. So I'm going to open that up. It's just the text file that came with your data. So we see in here, we start taking a look at what are we looking at. Okay, it's agricultural information for the year 2002 in Wisconsin. All right, but what does this help us? We see spatial domain, doesn't say anything for us. Keep scrolling for a while. There's not too much right away that we know that we need. So let's keep taking a look. So it should be, oh, I think I passed it up. It should be about a third of the way down. I'm just going to look it up. Where'd that previous one go? Ah, there we go. So when we see the spatial reference information, we can see that we're using a geographic coordinate system. All right, and it's the North American datum of 1983. So when we go back into here, what we need to do first is define our projection, right? We need to project our data. So right now it's nothing. So the easiest way to do that is first go to analysis, open up your tools, and let's just type in project. And we see there's a bunch of different options up here. So the project tool actually lets us project spatial data from one coordinate system to another. The problem with that is that this has an unknown coordinate system right now inside of ArcGIS Pro. So we can't really go from one to another yet. But if we define our projection, what it does is it overwrites any information that there is and assigns a new one. So let's go with that. So our input dataset obviously is going to be the Wisconsin Agricultural Census shapefile. We're going to set the coordinate system. Again, it's a geographic coordinate system. It's going to be North American. Depending on which version you are, you might have a subfolder called USA and Territories. Then we're going to do NAT83, and we'll use the 2011 model. So then we run it, and we see Wisconsin disappeared. So let's see where it ended up. Zoom back to our layer. Look at that. It's actually in Wisconsin now. That looks a lot better. But as we've learned in our class so far, we want to make sure that we're projecting our data to something appropriate. So North American datum is a lot closer than what we were, but it encompasses this entire area. So instead, if we go to our map and open up properties and pick a coordinate system, we can set our map to a more appropriate coordinate system. So let's do a projected coordinate system. I like to go with state plane. And again, NAT83 US feet. There it is. All right, and we're going to want Wisconsin. So let's scroll on down. But we see we have a central north and south projection for Wisconsin. Now, the area or any distortion to area isn't necessarily important for the purpose of this lab, right? We're just going to be looking at some agricultural data and some density information. So if you read the metadata, you'll know that much, but you should have read the metadata. So it's okay if we have some distortion of the northern and southern parts of our data. We just want it to look as generally familiar as possible. So I'm going to do that. It's going to reproject our data here. So now Wisconsin itself looks a lot more like Wisconsin. All right, so next thing we need to do is we need to create 5 choropleth maps, all right, for different types of data classifications. So right now we see everything is just one single color. If we take a look at our attribute table, we see in here, all right, we do have all kinds of different information. We could definitely set up classification methods, all right, but when you think about classification and what that means to our map right here, we're going to use symbologies. We're going to use groups to class everything. So we need to edit the symbology. So if you right click on your layer, you can hit symbology. And then we can see right now that our primary symbology is a single symbol. If we click it, we get all of our options. Now we know choropleth maps go from one color to another color, or if they're sequential, or if they're divergent, all right, they're going to go from a medium color. So we know that we need graduated colors. So right now we're on the right track, but we don't want to keep area as our field. We're going to be using M135 underscore 02. We know that we want to have 5 classes. It's ideal. Also, our instructions said to use 5 classes. Now, the first thing we can notice about our map is this negative 999 value. Now, again, if you read the metadata, you'll know that this means that there's no data in that area. And we know from class that that no data value is probably throwing off the rest of our classification. All right, so what we need to do is make sure we don't include it. So if you have the latest version of Arc Pro, you could click this button here for advanced symbology and data exclusion. If you don't, it'll be under the little 3 tab and you can hit advanced symbology options. And then it'll take you to this window. So once we get to our data exclusion, all right, we need to add a clause or a SQL statement, whichever one's preferable to you. But I'm going to do with the clause. All right, and we want to make it so where M135002 is equal to negative 9,999. That means is that this value is going to be excluded. So we verify it, it works, we apply it. Now we see we have identified where we have the negative values. But if we go back, we still see the no value here in our setting. That's just because it needs to be refreshed, all right? We haven't gone as far as adjusting our classification yet. So if you just get off of it and go back to natural breaks, you'll see it resets the entire thing. And now we have a more appropriate map. All right, now do note that the red here is a bit distracting. So for everyone in lab, I kind of showed some of y'all how to hatch. A lot of you figured it out. So just in case you don't know, you could pick the individual red layer. You can give it something just like a black outline, but then go to its properties. All right, and then we want to go, wasn't structure, was it? No. There was like an advanced one somewhere, and I keep forgetting where it was at. I'll remember it. Just give me a second. There we go. Yeah, go to the layers. So it's the different layers of that symbology. We could change our solid fill to a hatched fill. we can just use black lines to fill it. Hit apply. Now we have hatches in here. Hatches are a very common way to denote no data values in our data. So now that that's done, maybe we want to pick different color ramp. You can pick whichever one you want. But since we did that black outline here, you can see it looks a lot different with these gray ones. So maybe you want to take the extra time to come in, change outline colors, point widths, make them identical. So that one's, we did a 2-point. You know, just to make it consistent. You could go through and you could adjust each one of those if you want. Another thing I showed everybody in class was colorbrewer.org. Ooh, let's make that wider. So Color Brewer 2 was made by Cynthia Brewer, who is a famous cartographer. All right, and what she does is she gives us the ability to see some tried and true different color ramps. We could choose sequential, diverging, or qualitative colors that all kind of complement each other. Because sometimes the base colors you're going to get from ArcMap are going to be a bit intense. So do what you will. Feel free to use this. All you have to do is pick what format you want everything in. Remember the codes when you come over here. You can adjust each symbol and go to the color properties and decide exactly how you want to type it all in. So no worries. There's ways to export it and things like that, but we won't specifically go into it in this class. I'll leave it up to you to decide if you want to, get real fancy like that. Although I do encourage it. All right. So once we've done this, we see we have natural breaks. We're going to do quantile. We're going to do an equal interval, um, a geometric interval, and a standard deviation. All right. When you get to standard deviation, please make sure you use a divergent color ramp. All right. The other ones can all be the same, but this one needs to be divergent. All right. Once you make all of these maps here, all right, so that means coming in, creating a layout, and importing your map frame for each one. All right, I do want it for each one. Lay it out however you want. Add any supporting information. Maybe take a look at some of the stuff in the metadata. Please do all that. Add it all in. Make your full map. Feel free to publish your map to your ArcGIS Online account if you want to take advantage of the story map extra credit opportunity in lieu of the report, but that's okay if you don't. If you do a report, you did interesting things with your map, feel free to export images of your map so that you can have it in your report as well. It just adds additional supporting information, doesn't hurt. But that's it. You create all 5 of these maps for this lab. You could use the video resource that's included in the instructions to get your goodness of variance fit, which actually I'll take y'all through how to export that. And that's it, and then your report. So back to the goodness of variance fit real quick. Because after you've made your 5 maps, or at least gone through for the layers, you need to calculate that for each one. What you need is in your attribute table is to export your county and your M135021. So in order to try to clean up our table, we can come in here, we can create a definition query. Actually, easier than that. We'll get back to that one in a second. If we open up our fields view, we could see all of our different rows. We could click this one to turn everything off at first. Then we could turn on county, 13502, save our changes. And now this is what you got. If you're in the labs in CI229, you might need to hit the refresh button. that'll load it, reload all this for you. All right, so now that we have this, we still need to export it. So we're gonna have to go back to our toolbox, and we're gonna need to search for table to Excel. All right, so this tool just allows us to export this table in ArcGIS Pro to an Excel file. So we do that, it looks good. We run it. I'll open it up so we can see what it looks like. Wait, where did I save it to? Ah. All right, so now we see this is our table. Using the video from here, you'll be able to correctly go through all of this. So it might be helpful at this point to sort our entire data set and then remove our negative 9,999 values because they will throw off your goodness of variance fit substantially. So make sure those aren't in there. Then you can go back to sorting. Well, you're going to sort based on your classifications. So you'll still want these sorted like this. All right. Those instructions on exactly how to calculate that value are going to be in the other video that is attached to your lab instructions. All right, and you need to make sure that you're including that goodness of variance fit value somewhere on your map when you're designing it. All right, it needs to be on here. If it's not on here, you will lose points. All right, you also need to discuss it in your report. You need to think about that goodness of variance fit. Read about it if you're not exactly sure what it is from stats. All right, and then try to tell me which classification method you think was the best. All right, take into consideration that value, the way the map looks, just the whole thing. All right. Other than that, it's a pretty straightforward lab. Just do those things, write your reports, or create the extra credit story map, and get it submitted to Blackboard. All right, have a good one. Email me if you have questions.